So this is the second question. So a train travels for a total of 270 seconds along a straight horizontal track between two stations A and B. The train starts from rest at A and moves with constant acceleration for 60 seconds until it reaches a speed of v meters per second. The train then travels at constant speed at v meters per second before it moves with constant deceleration for 30 seconds, coming to rest at B. Sketch a speed time graph for the journey between the two stations A and B. So let's sketch that. And on the x-axis we're going to have t seconds, t in seconds, and we're going to have on the y-axis we're going to have speed in meters per second. So we know it starts from rest, so the speed is going to be 0, and it has constant acceleration for 60 seconds. I'm going to draw that a little bit deeper, so it doesn't really matter, I just have the space. So that's for 60 seconds, and then we know it maintains, so it reached a velocity of v, a speed of v, and then it maintains this for some amount of time. It doesn't tell us how long, so I'm just going to call that value the amount of time for which it's constant velocity t. So this is going to be 60 plus t seconds. And then it decelerates for 30 seconds. And if it decelerates for 30 seconds, and then this time here is 270 seconds. Now, because we know it decelerated for 30 seconds, I can actually get rid of this value here and say that that's 240 seconds. And we know that this t value, for which it remained constant velocity, is actually 180 seconds. That's your 2 marks there. So we need to label our axes and put our values 60, 240, 270 and v on there. Now part B says, given that the distance between the two stations is 4.5 kilometers, and to calculate the distance in a speed time graph, we need to calculate the area under the graph. Now to calculate this area, you can do it as two different triangles and then a rectangle in the middle, or we can see that this is a trapezium, and so we can calculate the area of a trapezium. So how do we calculate the area of a trapezium? So the area of the trapezium, and the area of the trapezium is half the sum of the parallel sides. So the parallel sides, the two parallel sides are there and there. So the sum of the parallel sides, half the sum of the parallel sides, so that's 180 seconds for the top parallel side and 270 seconds for the bottom one. So half the sum of the parallel sides times the distance between them. Half the sum of the parallel sides times the distance between. And the distance between the two parallel sides is that distance there, which is v. So we're going to times by v. And this whole thing is equal to 4.5 kilometers, which I'm going to convert to meters, which is 4,500 meters. Right, now 180 plus 270, that's 450, times by a half is 225. So 225v is equal to 4,500, and if you divide by 225 you get v as 20. And don't forget the unit is 20 meters per second, or ms minus 1. And the last part says, find how long it takes the train to travel from station A to the point that is exactly halfway between the two stations. Right, so find how long it takes the train to travel from station A to the point that is exactly halfway between the two stations. So we want to know when is it exactly halfway. So I'm going to remove all these lines. So we calculated the area, and we want to know when is it halfway in between. So we know that this area now, we want to know when it's this area here, let's call this halfway, and then say that this area here has to be 2,250. So this shape here has to be 2,250. Again, you can look at it as a trapezium. So I'm going to try and remove these blue highlighters. Let's see if I can get it right there and there. So we can say that this is a trapezium again. Okay, we know that this height here is 20 because we know v is 20 now. But we don't know this distance across the bottom. How much is that? We don't know. And we also don't know what this distance is. So let's say the time is some value t. Then this distance at the top in green is going to be t minus 60, because we know that this first bit was 60 seconds here. So if the whole thing's t, then that top is going to be t minus 60. And let's do the area of the trapezium again. So remember the area of the trapezium, so this is part C. The area of the trapezium is half the sum of the parallel sides. Sorry, it's t minus 60 for the other bit, times the distance between them, which we already calculated was 20. So half the sum of the parallel sides times the distance between them, and that's going to give us 2250, and that's going to be a half, and it's a half times 20, so all of this is being multiplied together, and so we've got a 10, and if I simplify the bracket inside, I've got 2t minus 60. Divide by 10, and you get 225 is equal to 2t minus 60. Add the 60 across, 285 equals 2t, and t is equal to 142.5. So that's one way of doing this question, and so you should have got 142.5 seconds. I'm just going to do it the other way, because some of you might have attempted it to do the other way. So, what is the other way? Well, what we can do is calculate the area of this triangle here, the first bit where the train is accelerating. So to calculate the area of that triangle, so I'm going to do area of triangle, that's the triangle, the height was 20, the width was 60, and it's a right angle triangle even though my drawing doesn't, there we go. Okay, so what's the area of that? That's half 20 times 60, and so that's going to be 600. So we know that the first bit where the train was accelerating, for 60 seconds it travels 600 meters. And we want to know when is it halfway, so we do 2250 take away 600, and that means, that gives us 1650. So now we know that the area where it was traveling at constant velocity, I'll do that in purple, that's this rectangle here. The bit where it was traveling at constant velocity is 1650 meters wide. Okay, now it's a rectangle, and the height is 20, and we don't know what this distance here, what the width is, so let's call that x for a second. So it's 1650 is equal to 20 times x, and so x comes out as, if you divide that across, you get 82.5. But remember, x is only the width of the rectangle, so 82.5 is the width of the rectangle, but it was already traveling at, it was already accelerating for 60 seconds, so the total time is 82.5 plus 60, giving us 142.5. So there were two ways that you could have done this question, but you still get the same answer both ways.